Hi, I'm Mike, N6MQL. I'm the Chief Engineer for RigExpert USA and PNC Engineering in the United States. We are the importer and direct distributor of RigExpert Antenna Analyzers into the United States. Today, we're going to take a little time to talk about the RigExpert Antenna Analyzer and compare its function and features, as well as how it differs from other antenna analyzers on the market. I hope you enjoy this presentation. Let's take a moment to talk a little about RigExpert Antenna Analyzers. All of the RigExpert Antenna Analyzers are made and produced in Ukraine by the RigExpert Ukraine company. RigExpert's been a trusted name for many years. They make T-hunting equipment, digital radio interface boxes, and of course, the antenna analyzers we'll talk about. All of these different pieces of equipment components have been used internationally for many years. Currently, there are 11 models of RigExpert antenna analyzers being made and sold. All of the analyzers measure continuously from their lowest frequency all the way up to their highest. These analyzers are separated into different categories based on their frequency range. For example, we have the HF analyzer. This covers from 60 kilohertz to 35 megahertz. The VHF analyzers that cover from 60 kilohertz up to 230 megahertz. We also have a model AA-50 zoom, which will cover the entire HF range into the VHF 6-meter band and just slightly above. The UHF models cover from 100 kilohertz up to 1 gigahertz, and finally the microwave analyzers that will cover from 100 kilohertz continuously to 2 gigahertz. There is a special model that covers the ISM band from 2.3 to 2.6 gigahertz, which allows spectrum analyzing of the Zigbee and Wi-Fi bands. But again, this is a special order only available through PNC Engineering in the United States. And for more information on that, be sure to give them a call or send them an email. So let's take a look at then and now. Many of you may be familiar with the older AA-30 and AA-54 units. Those had monochrome displays, they were 10-bit ADCs, and they used 100-point plotting on screen, as well as fixed 50 and 75 ohm native impedances. The new Zoom units have color TFT displays. They come in 12 and 16-bit ADCs, and they allow 20 to 500 points of plotting on the screen. They also give you the ability to do 25 to 600 ohms impedances, and those 300, 450, and 600 ohms impedances are excellent for testing ladder lines. The analyzers now give you the ability to loop graphs, and you also have a series of Coax tools that we'll talk about later on. The units also give you the ability to do Smith charting, and they have much faster speed than the older units. Let's talk a little about antenna analyzer designs and differences. The older style analyzers, and even some brands currently being produced and sold as current models today, employ an outdated circuit called the diode detector. To simplify that circuit, voltages are measured across a series of diodes and a single resistor. Those voltages are what determine the resistance and reactance of a load or antenna connected. Some types of diode detector analyzers react in such a way that the R and X values are just added together to create an impedance of an antenna. This becomes an issue when the pure resistance or reactance of the antenna are too far from resonance. This type of diode detector analyzer will show a load with, say, 25 ohms of pure resistance and 25 ohms of imaginary or X reactance as close to a 50 ohm impedance. This would cause an antenna analyzer to read a 1.2 to 1 SWR, when in actuality, the true SWR would be closer to a 2.5 to 1. Another issue with these older circuits is the LC oscillator. The biggest issue with the LC oscillator is that it can become very unstable as the temperature varies. Maybe you've seen this with one of your current antenna analyzers. You've dialed in the frequency that you want to check, and then you let go of the knob, and all of a sudden you're no longer on the frequency that you were trying to measure. Or maybe you set the analyzer down on the ground outside in the hot sun, and it just never stopped changing frequency on you. Well, to avoid this, RigExpert antenna analyzers have been designed as vector network analyzers. First, they measure the complex voltage across and current into the load or the antenna. The analyzer, by way of a calibrated return loss bridge and a detector circuit, then send that information to the CPU to make a complex mathematical impedance calculation. And that information results in a very accurate SWR, reactance, and resistance measurement. So to resolve issues like the drifty LC oscillator, RigExpert designed their analyzers with a dual DDS circuit. This DDS system is extremely accurate and remains stable regardless of the ambient temperature inside or out. That means when you enter the frequency into the analyzer that you're trying to measure, the RigExpert maintains that frequency with great accuracy. Also, the DDS circuit allows the RigExpert analyzers to obtain high UHF and microwave measurements with the same extreme stability. I'm often asked which analyzer should I purchase. My advice to those who ask is first to look at the need for the application. What's the highest band that you're going to operate in? Do you believe you may extend your frequency range in the near future? What types of antennas do you own and operate? For example, say I work up to 440 megahertz on the 70 centimeter band. Does that mean that I need an analyzer that goes all the way up to 650 megahertz? Well, maybe not. Let's look at the type of antenna I'm using. So maybe I've only got a 2-meter, 70 centimeter radio in the car. So far, I've been able to key the repeater, and I don't hear any static coming back. So generally, I'll tell people who have only a 70 centimeter radio in the car, maybe it's not necessary to spend the extra money on the 650 megahertz analyzer. After all, once you tune that tiny little whip antenna on the car, less than an inch, and then drive away, the ground plane beneath the vehicle is going to change as soon as you pull off. Also, the little antenna will most certainly be bending and changing in the wind while you're driving. So maybe for that person, we really only need to get a 2-meter antenna analyzer. Now, say that same person has a home station with a 70 centimeter band set up, and they operate with a Yagi or a J-pole or other larger type of home station antenna. Well, in this case, I would most certainly suggest that those people purchase an antenna analyzer that covers all the way to the 70 centimeter band. These type of antennas require much more accurate adjustments and require more movement than the 1/16 of an inch you may have had to move with your tiny little mobile whip antenna. Another reason to purchase a full-featured analyzer, say one that goes up as much as 2 gigahertz, is because you're like me. You love designing and testing different types of antennas. You'd love to do that, and you need the tool to do it correctly. You'd be remiss not to have the proper tool in your toolbox while endeavoring on those types of experimentations. This would be like trying to build a house without having the proper hammer. Budget, and this means the wife, the husband, and the family. They all come into consideration. I would suggest to anyone who doesn't have the proper budget for the proper tool for the job to just wait until the ability is there. There's nothing like having to purchase a second analyzer only to replace the one that you just bought. Now, if you have deep pockets, the sky is the limit. Why not get the best analyzer for the money you have available? After all, maybe you'll end up pushing your frequency limits higher in the future, or maybe you just want as many of the features on an analyzer as you can get. So RigExpert has analyzers from as low as about $200 US all the way up to as much as the $1,000 range. At the end of this video, I'll have a link to the RigExpert USA comparison table, and that'll give you some good ideas on what's available to you. Let's have a look at what the antenna analyzer can actually do. SWR. Everybody wants to know their SWR. Well, SWR is displayed in 5 different screens with 3 different static modes. You have the graph mode, the Smith chart, the multi-SWR mode, analog metering, and the all screen. So let's have a look at each of these screens individually. First up is multi-SWR. The multi-SWR mode is a very powerful tool. It allows you to look at up to 5 bands or 5 frequencies of SWR simultaneously. That means that I can have a multi-band vertical antenna, in this case 10 meters, 12 meters, 15, 17, and 20 meters all at one time. So, for example, maybe I have a vertical antenna where I've got all of these bands on this antenna, and I want to adjust my 20-meter trap, but I need to know what's going on with the 15 and the 10-meter band at the same time. Maybe if I adjust 20 meters, it's going to drastically affect those 15 and 10-meter bands at the same time as I change it. So I can monitor that by simply looking at all 5 of these bands at the same time and adjusting and having a look to see how I'm affecting the other bands. Maybe I'll be able to save the time from having to take the antenna down and readjust 10 because I made a change on 20 that was very drastic. Next up is analog metering. It's exactly what you'd expect, a representation of an analog meter. But we've also added the ability to see what the meter is trying to display right below it. You can see it's telling you you have a 1.13 to 1 SWR. And for those who enjoy reading return loss, you can also see that we've provided you with the 25 dB return loss reading. Now let's look at SWR graphing mode. This mode is really powerful. This mode gives you the ability to see an SWR curve across a bandwidth that you select. As you can see, we have set a center frequency of 14,100 kilohertz or 14.100 megahertz, and we've set that to plus and minus 1,000 kilohertz wide. So that means we have 1 megahertz below the center and 1 megahertz above the center. That gives us a total bandwidth scan of 2 megahertz. So what we can see first is at the top of the screen, in that center frequency of 14.100 megahertz, we have a 1.13 to 1 SWR indicated by the triangle and the vertical line at the center of the scan. However, if you look at the bottom of the screen, this is what I call Analyzer for Dummies. You notice it tells you that we have a minimum SWR of 1.12 at 14.060 megahertz. So this is telling us that, in fact, we have a better SWR point within our bandwidth scan of 2 megahertz than we do at the center frequency of 14.100 megahertz. This gives us the ability to find the lowest SWR within any bandwidth that we scan. And of course, that bandwidth can be increased or reduced, and we'll talk about that in a little bit. Next up is the Smith chart. Anybody who reads a Smith chart knows how powerful this screen really is. In this one screen, we can tell the SWR, the reactance, whether it be capacitive or inductive. We can also see the resistance, whether it's high or low. On the screen, you'll see that we have the constant resistance circles, or the great circles, and we have the constant reactance curves. So all of the information is given to you on this Smith chart. You can also see by way of the red dot cursor that we're sitting at 14.100 megahertz or 14,100 kilohertz, and that the entire circle that it's making on screen is the 2 megahertz bandpass that we originally programmed. So this is just another view of that SWR graph that we made. In this graph, though, we can see that this antenna is clearly going from capacitive reactance into an inductive reactive state, and that we're very close to that 1-to-1 SWR. So the Smith chart gives us a lot of information in one view, so we can tune an antenna to resonance with ease. Finally, we have the All mode. In the All mode, we can see all of the information simultaneously at a static frequency. So in this case, again, we're at the 14.100 megahertz or 14,100 kilohertz. And we can see that the SWR is 1.13. We have an impedance of 48.5 ohms. We have a return loss of 24 dB, and the phase is at 104.4 degrees negative. Also, which we'll get into in just a minute, we can see RX and LC values. Those will come in just a minute. A really important feature of any antenna analyzer is its ability to accurately measure pure resistance, reactance, and resonance of an antenna or a load. The reason you want this is because resonance of an antenna will dictate how much of the energy you send to your antenna will actually be transmitted by the antenna. One of the things that I find, and very often, is that although the SWR may be low on the frequency you're trying to tune for, the actual resonant portion of that antenna may be as much as 100, 200, or even 300 kilohertz away. In some cases, this may even be out of the band limits of the frequency you're trying to operate within. It's important to be able to have the information that allows you to see where your antenna is actually resonant. Once you know this information, you could then make proper adjustments to the reactance. In many cases, this involves shortening or lengthening the driven element, a whip, or the sides of a wire antenna, such as a dipole. First, let's have a look at the three different views that the RigExpert antenna analyzers provide for reactance, resistance, and resonance. We have the graph mode, the Smith chart view, and the all mode. Let's look at an example that I gave with a relatively low SWR. Here on the all mode display, you can see that the SWR indicates a 1.13 to 1 at 14,100 kilohertz or 14.100 megahertz. For most of us, that would be considered a very close SWR. We can also see, looking at the all mode display, the L, or inductance, is at minus 64.9 nanohenry, and the C, or capacitance, is at 2.0 nanofarad. But is our resonance really tuned to the upper portion of the CW band? Well, looking at the graph mode of RX, we can see that our antenna is indeed capacitive reactive at that 14.100 megahertz, or 14,100 kilohertz. Just as our SWR graph indicated, we can now use what I once again call Analyzer for Dummies. And we can see that at the bottom of the display, we're being told that within this 2 megahertz bandwidth scan, our actual calculated resonant point of this antenna is at 14,326 kilohertz or 14.326 megahertz. This is 226 kilohertz away from our 50 ohm pure resistive point. Not to dig too deep into antennae theory, but I know some of you are thinking that perhaps there's another resonant point just below the 14,100 kilohertz area. Well, moving that reactance point up would actually cause the SWR to increase because the resistive value that would probably follow with it would be off. This is why seeing the analyzer calculated resonant point is so important. These types of things, when you purchase from RigExpert USA or PNC Engineering, we love to discuss on the phone or through email. So when you purchase through us, you'll get this type of support. A lot of other antenna analyzers on the market measure SWR. Some even graph it. Others may test pure resistance and reactance, but what sets the RigExpert antenna analyzers apart from all others are its test modes. Like the special set of Coax tools, all of the RigExpert Zoom series antenna analyzers, with the exception of the AA-2000, offer the ability to test and measure coax cable for the following items. Stub match tuner, the length and velocity factor of a coax, the cable loss of a coax versus frequency, and the cable impedance versus frequency. Let's talk a little about each of these coax tools. First up, the stub tuner. The stub tuner helps you tune a piece of coax to a perfect quarter wave or half wave stub frequency. The first thing you want to do is cut your coax length about a foot longer than your standard quarter or half wave stub frequency. Next, simply connect the coax to the analyzer and start the measurement tool. The RigExpert Antenna Analyzer will then immediately tell you the exact frequency of the quarter and half wave stub match of the cable. To tune the stub match, simply make small cuts to the coax until it reaches the exact frequency you plan to operate it on. This is a great tool for those who are making phased verticals and need to have one coax a quarter wavelength and the other a half wavelength at the same exact frequency. It's also excellent for making 75 ohm stub matches that will impedance match your vertical antennas. There are many uses for the stub tuner, and you can find more about these reading the ARRL Antenna Handbook. Next is the Cable length and velocity factor tool. This tool allows you to do two things. First, check the velocity factor of a cable if you know the actual length, or if you don't know the length but you know the velocity factor, you can find out the length of the cable. When would you use this? Well, when the manufacturer tells you that the velocity factor of their cable is 0.66, but you're having difficulty with the cable, you can check it by putting in the exact length of the cable and measuring it and finding out maybe you have a 0.68 velocity factor. Or maybe you know you have a 0.66 velocity factor, but you're going to the swap meet and somebody tells you that they have 100 foot of coax used and they want $40 for it. Well, you put your antenna analyzer on it, you run the tool, and you find out that they only have 72 feet of coax on that reel. Now you know what you're dealing with. Don't want to get home and find out that you have short ends. Here's a very helpful coax tool, the loss versus frequency. With this tool, you can find the exact decibel loss of a coax at the frequency of your choice. Simply connect your coax to the analyzer. You'll be instructed to make an open and a short test on the coax. Once done, the RigExpert Antenna Analyzer will then plot a dB scale from 100 kilohertz all the way up to the maximum frequency of your analyzer. In this case, we can see that we have a loss graph from 100 kilohertz to 55 megahertz. With this, you can then now move your cursor to the left or the right to see the exact dB loss at the frequency you place the cursor. In this graph, you can easily see that this piece of coax has a 0.29 dB loss at 27,500 kilohertz or 27.5 megahertz. This is a helpful tool when you want to be sure that you have the lowest possible loss on the band or frequency that you plan to operate it on. For example, if you have a 40-meter antenna and you want to know that your coax doesn't have any extra loss in the 7 to 7.35 megahertz area, simply run this test, move the cursor to the 40-meter area, and check the loss of that piece of coax cable. Another very helpful coax tool is impedance versus frequency. With this tool, you can find the exact impedance of a coax at the frequency of your choice. Simply connect your coax to the analyzer. Once again, you'll be instructed on screen to make an open and short test of the coax. Once done, the RigExpert Antenna Analyzer will plot an impedance graph from 100 kilohertz all the way up to the maximum frequency of your analyzer. Once plotted, you can then move your cursor to the left or the right to see the exact impedance in ohms at the frequency you place the cursor. In this graph, we can clearly see that this piece of coax has an impedance of 51.8 ohms at 27,500 kilohertz or 27.5 megahertz. With this tool, we can both make sure that the coax we're purchasing is of the highest quality and has the most accurate impedance possible. If the manufacturer tells you that our coax is 50 ohms, we can accurately check to see if they're holding to industry standards. Another great use of this tool, like the loss versus frequency tool, is the ability to check our coax from season to season. Why? Because one cause of poor operations in a station is UV light. As the sun bakes our coax, the loss and the impedance may change dramatically. Although most of us never do, the major manufacturers of coax recommend that we replace our outdoor coax every 10 years, if not less. With the brand new RigExpert Stick Pro, the AA-230 Zoom, and all of the RigExpert models above that one, you'll receive a time domain reflectometer. The TDR tool, as it's also called, is a powerful function that was never available on a handheld antenna analyzer other than the RigExpert analyzers before it. The TDR tester, traditionally a much larger bench-made piece of equipment, would cost in the thousands of dollars. Well, RigExpert has made this test feature available to their owners as a free addition. The TDR tool allows you the ability to measure coax faults. This includes things like an open in the coax, a short, or even damage that's happened due to bending of the coax, or that one time you laid the coax down in front of the garage door while testing an antenna, and the wife or the husband came driving in over it, crushing it. You'll also be able to see rodent chewing, or as I've seen in some broadcast towers, birds pecking at the coax. And of course, you'll be able to see damages on working coax, such as water intrusion and heat damage. And the list continues on. The DTF, or distance default, will find and display anomalies to within about 3/4 of an inch of the damaged coax section. It will also continue to show you the condition of the rest of the cable after that damage. The RigExpert Antenna Analyzer's time domain reflectometer simultaneously measures and displays both in impulse and step response. In this screenshot, we can clearly see at 9.17 feet, we have an indication of a dead short in our cable. This also is marked by the cursor at the top of the screen. Had this not been a complete short and only a lesser type of capacitance or inductive anomaly, such as crushed cable, we would have then been able to move the cursor farther to the right, where we could continue to look for any other damages that may occur within that remaining cable. Another great feature about the RigExpert Antenna Analyzers is their ability to draw blue lines indicating the regions within the ITU regulated ham bands. You have the ability to change language and ham band ITU regions for different countries. For example, if you live in Europe, then you would use ITU Region 1. If you live in the Americas, you would then select ITU Region 2. The ITU band designations can be updated as they're changed via firmware. You also have the ability to display measurements in both metric and imperial values. I've been asked before, why are some of the analyzer models called zoom units? Well, the zoom feature on the RigExpert Antenna Analyzers allow you to change the level of a displayed graph. You can adjust the zoom level both in the X and the Y axis. For example, after completing a scan, simply use the arrows to choose your optimal SWR Y axis. Perhaps all of your SWR or reactance and resistance values are very low. In this case, you may want to zoom into the Y-axis in order to change the displayed 1 to 10 SWR scale to a 1 to 2 to 1 SWR scale. Now you can really see in great detail where that SWR curve is graphed. On the X-axis, you now have the ability to change the bandwidth of a displayed graph. This gives you an opportunity to zoom in and out of an already captured graph showing SWR or reactance and resistance. Think of it like when you take a picture on your phone or your smart device. You pinch and expand the screen. The X-axis works just like a magnifying glass, allowing to get an even closer view of a selected area of the on-screen information. With the zoom tools, you never have to guess or continuously rescan your SWR and RX graphs in order to get more detail in a graph. We haven't talked much about two of the newest RigExpert Antenna Analyzer products. These are the ultra-compact, handheld, and pocket-sized stick analyzers. The stick analyzers come in two versions. The first is the RigExpert Stick 230, the other, the RigExpert Stick Pro. Two very different types of analyzers with the same compact size. The Stick 230 features a 200 by 200 pixel paper display, which requires very little power from its onboard rechargeable battery. The Stick 230, as its name implies, covers from 100 kilohertz to 230 megahertz. It doesn't have a backlight, so it's most likely meant to be used indoors or where very bright sunlight could otherwise be an issue with screen visibility. Its features are somewhat limited to SWR graphing, mult mode, and static mode resistance and reactance readings. Whereas the Stick Pro covers from 100 kilohertz all the way to 600 megahertz. The Stick Pro features a bright color 200 by 200 pixel LCD display. The Stick Pro also has all of the same features as the analyzers we've been talking about so far, with the exception currently of the zoom mode for SWR. Otherwise, you have a full SWR band and free mode graphing multi-mode, which is similar to the multi-SWR mode, which we'll talk about in just a minute, and all of the Coax tools, plus a feature or two that are not on the other analyzers. The Stick Pro is a full-featured analyzer that fits in the smallest and lightest of your soda go bags. As I mentioned, there are small differences between the Zoom Analyzer's multi-SWR mode, which we covered earlier. If you recall, we talked about the 5 frequencies or 5 bands that measure SWR simultaneously. Well, the Stick Analyzers use a slightly different method. With both the Stick 230 and the Stick Pro, they have the unique ability to check every band of the current ITU region selected for SWR and reactance, this in less than 20 seconds. For example, if you are in the ITU region 2, or the Americas, then the Stick Analyzer will quickly scan all 17 bands for their SWR. Once completed, the analyzer will then report on screen with the lowest SWR within each of those bands. Don't worry if your antenna is slightly out of band. The analyzer will catch that as well, as it also checks just below and just above each band, knowing you won't always be exactly where you need to be. If the analyzer does not see an SWR that's lower than 3 to 1, then it'll exclude that band from the displayed list. On screen, you'll be able to see 2 references. The first is the actual SWR number, for example, 1.25, and it will also display a series of stars. The stars range from 1 to 5 stars, 5 stars being the best possible SWR. The star scale allows for a very quick view of how resonant and low the SWR is on each of the bands that it's displayed. So, if you have a vertical or other multiband antenna and you don't know what bands it covered, by making a very quick 15 to 20 second multi-scan of the antenna, you would quickly know which bands the antenna was most likely usable on. One analyzer noteworthy of an extra mention is the flagship and brand new AA-2000 zoom. The AA-2000 zoom covers continuously from 100 kHz to 2 GHz. The AA-2000 also has some special features that the other analyzers don't. These include an LC meter. The LC meter provides the analyzer with the ability to directly measure capacitors and inductors in 3 different modes at frequency. With the AA-2000 zoom, you also receive extra display modes such as the 3 different views of the polar and Smith chart, SWR measurements including graphing, analog metering, and trend mode, which allows you to see SWR changes over a continuous moving time frame. You'll also receive both the MULT and the multi-SWR display modes I talked about. Finally, but not last, the RigExpert AA-2000 zoom provides a high-definition 400 by 800 pixel bland view LCD display, which is viewable outdoors. With any technology product, there will always be change as the product evolves. RigExpert has thought about this and made it easy for its owners to keep current with any changes that may occur. Firmware updates are always free. Using a very small flash program, RigExpert provides the ability for all of its Zoom series antenna analyzers to be updated through the internet. Simply connect your analyzer to your PC or Mac computer, select Update from the internet, and 30 to 60 seconds later, you'll have the most update firmware available. It's just that simple. All RigExpert antenna analyzers come with a full 2-year RigExpert Care manufacturer's warranty. PNC Engineering is an authorized RigExpert Care warranty component level center, so you can make your purchases from us with total confidence. For the best service and support, I recommend that you make your purchases through rigexpertusa.com or pncengineering.com. When you do, you'll receive our exclusive technical and operational support via telephone, email, and the RigExpertUSA.com live chat window. This is a service only available to customers of RigExpert USA and PNC Engineering. I hope that you found this video to be informative and helpful in selecting the best analyzer for your needs. Please be sure to contact us in the future with any pre-sales questions. Have a great day.